Frank and Joan are at Mr. Grant's hardware store. The flashlight on Joan's bike is not working. Joan will ask Mr. Grant to check it for her. Mr. Grant knows that Joan bought new batteries just the other day, so perhaps the bulb needs to be replaced. There. Now it's working. But why didn't it work before? What's wrong with the old bulb? Let's look at it very closely. The little wire right here is broken. And that's why the flashlight didn't work. That's interesting. How does a little piece of wire make the bulb light? Could Mr. Grant explain that? Yes, he can. He has some simple equipment that he put together last year to explain electricity to his own son. Now he'll show it to Frank and Joan. First, he tells them about the kind of battery he's using. This battery, just like the flashlight batteries, is safe to handle because it produces only a small amount of electricity. But the electricity that we use in our homes is not safe for us to handle for experiments. Mr. Grant has the battery and wire so arranged that electricity can flow in a complete pathway from one battery post through the wires back to the other battery post. But is the pathway complete? Not quite. Now Mr. Grant will use another little piece of wire that will complete the path. There, the wire is connected. Is the pathway complete? How can we tell? Mr. Grant asks Frank to shield the light. Now in the shadow, we can see that the little wire is glowing red. This shows that electricity is flowing through the wire. If the little wire is disconnected, the path is not complete and no electricity flows. Frank sees that the disconnected wire is like the broken wire in the burned-out flashlight bulb. But when Mr. Grant connects the wire again, the electricity starts to flow once more, and we can see red light as the little wire glows. The wire is producing light and a lot of heat, so we must be careful not to touch it. The many wires in an electric toaster produce even more heat. This is one way we use electricity, to make heat. An electric heater produces heat, and so does an electric range. These are just a few of the things that make use of electricity to produce heat. But how does electricity make light? Mr. Grant is going to show them using another battery and other wires. He has passed two wires from the battery through a rubber stopper. Now he connects the wires together with another kind of wire that is very thin. He then slips the wires and stopper into a bottle. It's a homemade light bulb. As soon as the battery is connected to make a complete path for the electricity, the wire begins to glow. But the glowing wire burns out quickly in the homemade light bulb. That was interesting. Can we see the wire produce light again? We'll use another piece of thin wire. Once again, the wire glows, but quickly burns out. In the flashlight bulb, The glowing wire burns a long time, just as it does in an ordinary lamp. That's because the air has been removed from within the glass bulb. Special thin wire is used which does not melt, but continues to glow with a bright light. Electricity makes light for many different uses. For railroad signals, traffic signals, for automobile headlights and tail lights, for giant searchlights and signs. Electricity may make different kinds of light. Neon lights give off colored light. These fluorescent lamps give off very white light. In fluorescent and neon lamps, there is no wire that glows. Instead of flowing through a wire, electricity flows through gas in the tubes. Mr. Grant tells Frank and Joan that so far they've seen that electricity can make light and that it can make heat. Now Mr. Grant is going to try something else. He's wound some wire around a nail. In place of the wire that produced heat, he's connecting the wire wrapped around the nail. Now, once again, the electrical pathway is completed. The electricity flows from the battery through the wire wrapped around the nail and then back to the battery again. What does this do? The electricity makes a magnet. It's an electromagnet. It can pull things, attract things made of iron and steel. These magnets are called bar magnets. They too can pull things, attract these steel paper clips. The magnets are marked to show the North Pole and the South Pole. We know North and South poles attract, pull towards each other, but the two North Poles or two South Poles repel, push away from one another. Let's try it with three magnets. By using the pushes and pulls of magnets, we can make the magnet in the middle spin. Joan and Frank think that the spinning magnet swings around something like a little motor. Mr. Grant says he'll show them a little motor that is made of magnets. Instead of 3 bar magnets, it uses 3 electromagnets. Each is made of a nail wrapped with wire. The center electromagnet is free to turn, just like the center bar magnet could turn. As soon as Frank completes the pathway, the motor begins to turn. Here electricity is producing motion, this turning motion, using the pulls and pushes of magnetism. The little motor can do little jobs. It can turn a paper fan. A larger electric motor turns a real fan. An electric motor turns a mixer. Very large electric motors turn train wheels. Joan and Frank thank Mr. Grant for repairing the flashlight and for showing them some things about electricity. Now, Frank and Joan know that electrical things work only when the electricity flows through a continuous pathway. Electricity flows through these thick wires and produces heat. Electricity flows through this thin wire and produces light. Electricity can make electromagnets that produce motion. So Mr. Grant has been very helpful. Both Frank and Joan have learned some things about electricity and about some of the ways it can be put to work for us.